Welcome to P40 Agile Enhanced 106 PSL Programmable Scheme Logic Editor Training video. In this video, we're going to cover these topics: Introduction of the PSL Editor, Input-Output Signals, LED Contact Conditioner and Timer, Logic Gates like AND, OR, NOT gates, and SR latch gates, and finally the flex elements. We can use it to create a protection element. And now let's get started. We have learned the configuration of the different digital inputs and outputs, especially that operands list over 1,000 items in the modules of 103. We can combine these inputs and outputs to customize them to specific applications with the PSL Editor Programmable Scheme Logic Editor in the NVISTA Flex software. The PSL Editor can be launched by clicking the Logic tab on the NVISTA Flex toolbar. And this can be done when communicating with the device through the Quick Connect or with the offline CID in the created project. So by default, there is a minimum toolbar, but the user can choose to display the other tools under the menu view. So for example, we can choose the drawing toolbars and the nudge toolbars and the grid property. So with the drawing toolbar, we can add in the text on the canvas. And when you hover the mouse over each icons on the toolbars, so you can see the functions: zoom in, zoom out, zoom, zoom to fit, pan, the text, and the link. Input signals, output signals, LED conditioner, contact conditioner, timer, AND gate, OR gate, and SR latch gate. So here, the pan is used for moving the icons on the canvas, and the link, this is to connect the two different inputs, outputs to the logic gate, etc. And some functions can also be accessible when you right-click a mouse. You can choose to set the grid function, for example, and the zoom in function, and you can choose zoom to fit. The PSL Editor lets you allocate different logic inputs or the operands to different operators, then assign to the different outputs. The operands to the PSL is any combination of the status of the digital input signal from the opto inputs, virtual inputs, virtual outputs, relay outputs, goose remote inputs and remote outputs, any outputs of the protection, control, and monitoring elements, non-volatile latches, flex elements, and any internal signal available as flex logic operand. We had learned the operand list from the module 103, and now in the next session, we're familiar with each operand under different categories. The operator can be AND OR gate with inversion option, and the timer and SR latch gate. The output of the operator typically is the virtual output, but can also be the programmable LEDs or the output relays. And in the end, these LEDs and output relays are still using the virtual outputs. The relay output contacts and the programmable LEDs have dedicated conditioner to create the delay for pickup, dropout, or post output, etc. The PSL logic is saved in the CID file when the setting file is written to the relay. Then the logic will be updated. During the online mode, when the PSL editor is closed, the logic will be uploaded to the relay. The PSL logic is event-driven. Only the part of the PS logic that is affected by the particular input change that has occurred is processed. This minimizes the amount of processing time used by the PSL, ensuring the industry-leading performance. The input signals are saved under the different categories. There are different types of the categories, and the total number depends on the Cortex order code. For this demo, P40 RGL Enhanced P14DL relay, it has 39 categories. Some categories has only single operand, for example, the category 1 and 2, that has the only on and off, and some has the multiple operands, like the third one, contact inputs on, which has 11 operands. The same for the category 4 is contact inputs off, it has 11 operands. Then the contact categories 5 and 6 are the virtual input on and off. There are totally 128 on and off for each categories. The category 7 and 8 are for the virtual outputs on and off. The same, it's 128 on and off for each. Then the relay outputs on and off combined into one categories. There are 12 relays, but without the relay 8 as an operand. So that's the category 9, and category 10 and 11 are for the remote input on and off. There are totally 128 remote input on and off for each category. The category 12 will be the remote output on, and that's totally 32 remote outputs on and off for each category 12 and 13. Category 14 will be the remote goose offline. That's totally 32 plus one generic at the bottom. There's one generic offline. Okay, so that's the category 14. Then the 15 will be the DPS. It has totally 16 for underscore 1 and 2, and each one has on and off. Then we have from the category 16 again, it become single operand, any trip. 17 is any alarm. 18 is any block. The 20 is any operate, OP, and 21 resetting is a multiple operand. 22 set point access, and 23 is the targets. 24 is the relay service. 25 is testing. 26 is self-test error, and 27 is a data logger. It has only one operand, is data logger alarm. And then the 28 is a critical failure relay. 29 is a status. 30 is output relay voltage monitoring. And from 31, it started the protection category. And the first one is a protection product. Only for one element is undercurrent, hence CDOS number 37. It has trip alarm for pickup and operate. So the next one is the biggest category is the protection currents. It has all the IOC, TOC, pickup and operate, operand and other ground, operand, etc., and has the thermal and all the current operand except the undercurrent, which is saved under the protection product category. The next category is 33, will be the voltage element, same for all the under and over voltage. And the next will be the power element, over under power, and the frequency. There's over and over under frequency and frequency rate of change, DFDT, and each element has the protection, the NI element, and also the pole dead is also saved under the frequency element. And the monitoring element, that's all the monitoring elements, and the 37 is the control element, 38 is non-volatile latch gate, has a 16 on and off, and the last one, the category 39, this is the flex element. So this has 8 flex element, for each one has a PKP and OP. And that's all the 39 categories. We can review them again. And this 39 categories just for this P14DL order code. And if you have a different type of the P40AE enhanced, different Cortex order code, you may have a different categories. For example, the P14N, you may not have this voltage element category. In the previous demo of the contact input, we used the UK English as the setting for the language. When the language is set to the US English, the types of the operand are the same, but the element may be different under the category, especially for the protection element. So under the US English, there's no greater sign for the over current. Instead, you're using the start and the trip for the operand. The output has only one category, is assigned virtual output, which has totally 128 virtual outputs. And this virtual output can be used as a signal input, as we mentioned in the previous session, is category 7 and 8. And for the user, they can only use the virtual output until 1 to 109. This is the usable, and from 110 to 128, these are reserved. If you select 110 or to 128, any virtual output, you get a warning message. These are reserved for contact outputs and LED. Please use other virtual output available in the list. So from the virtual output 110 to 120, these are the reserved for the relay 1 to 12, among which the 8 is a fail safe, so there's actually 11 relays, and from the 121 to 128, there's 8 virtual outputs. These are the reserved for the LED inputs, red and green, and from LED 5 to 8, there are 4 LED. Each one gets 2 inputs, so there's totally 8 inputs. That's reserved for the 121 to 128. The LED has 2 inputs for the red and the green, and each input will illuminate the relevant LED color, red or green. When both are asserted, then it will illuminate the yellow color. And there is a latch settings checkbox to set this output color to be latched, and it can be reset with a reset command once the condition has been cleared. And once LED is used on the covers, then only the unused LED will be displayed when you grab the LED from the toolbar. So far, so on. There are 11 output relays can be used for the configuration in 7 different modes: pickup, dropout, the well, pulse, pickup and dropout, straight through, and latching. In the pickup mode, only the pickup values is programmable in milliseconds. When the input signal goes high, the timer waits for the pickup delay time, then drives the output high. If the input drops off while the pickup timer is in the process of expiring, the timer immediately resets. Only when the input signal goes high again and lasts longer than the pickup delay, then the output goes high. In the drop-off mode, only the drop-off values is programmable in the milliseconds. When the input drops off, the timer waits for the drop-off delay, then drives the output low. If then the input picks up again while the timer is in the process of expiring, the timer immediately resets. Only when the input signal goes low again and lasts longer than the dropout delay, then the dropout goes low. In the well mode, only the pickup values is programmable in milliseconds. In this mode, when the input signal goes high, the dwell time immediately drives output high for the pickup delay time. If the input is low after the pickup delay expires, then the output will go low. However, if the input is not low, then the output follows the input until it resets. A dwell is the minimum time that contact will be on, and it's used for the trip function to ensure a good quality of trip signal is obtained. So for example, in a dwell timer setting, a dwell of 100 milliseconds means that the initiating signal is on for 10 milliseconds, then the output contact is on for 100 milliseconds. And if the initiating signal is on for 200 milliseconds, then the output contact will be on for 200 milliseconds. In the next pulse mode, only the pickup values is programmable in the milliseconds, and the pulse mode is used to create a pulse of fixed duration of the pickup values on the output regardless of the length of the pulse on the input. And this is the main difference with the dwell time mode. In the next pickup and dropout mode, both pickup and dropout values are programmable in the milliseconds, and this mode combines the functionality of both timers to produce delays on both pickup and drop-off. In the straight-through mode, neither pickup nor dropout values is programmable. The output signal follows the input signal straight through, means there's no conditioned in any way. In the last latching mode, same as the straight-through mode, with no values are configurable. The input signal goes high, the latch will be immediately drives the output high until the latch is reset by the reset command. And latching is used to create a sealed-in or lockout type function. There are 32 timers which can be used to create the time delayed condition with pickup and dropout. There are 5 modes: pickup, dropout, the while, pause, and pickup and dropout. These properties are the same as the contact output conditioner. For the timer and the output contact, when they are used, so the remaining will not shown until all the timers and the contacts are used, then the toolbar will be grayed out. So this is the same for the LED, for the output contact, and for the timer. So only the remaining timer will be displayed. And for the timer, you cannot see how many available, but once all the 32 being used, they'll be grayed out. Once the PSL editor is closed, the configured LED output contact and timer can be checked under the settings. The LED is under the device, front panel, programmable LED, and you'll see that reserved VO virtual output 121 to 128 will be assigned here, and the output relay is here. If you have any virtual output, this will be assigned here, and lastly is the flex logic and the timer. So you can see that the timer mode or the pickup or delay depends on which mode you're in. If you're in the pickup and the dropout, you'll see both settings. So that PSL editor configured settings all can be checked from the setting tab. There are 3 gates in the PS editor: AND gate, OR gate, and SR latch gate. For the AND gate, requires all the inputs are true for the output to be true. For the OR gate, requires one or more input is true for the output to be true. And each gate has an invert output checkbox, which equals to a NOT gate applied to the output. And we can see a circle as the output gate. And also each gate can be converted into another gate by switching from inside settings. So we can switch the AND into OR gate, vice versa. The SR latch gate has set and reset inputs, and this SR latch gate in the PS editor is volatile, which means when the power is lost, that the output latched output will be reset. And for this SR latch gate is the reset dominant. Under the flex logic non-volatile latches, there are 16 non-volatile latches settings here. The purpose of a non-volatile latch is to provide a permanent logic flag that is stored safely and does not reset when the relay reboots after being powered down. A typical application includes sustaining operator commands or permanent blocking the relay function, such as auto-recloser, until a deliberate HMI action resets the latch. Non-volatile latch can be set to reset dominant or set dominant. From the comparison table, we can see the main difference is that when the both S and R inputs are set to on in the set dominant mode, the non-volatile latches on output is off. In the reset dominant mode, the non-volatile latch on output is on. The other 3 scenarios are the same for both reset dominant and set dominant non-volatile latched type. There are 8 identical flex elements under the flex logic flex element setting. A flex element is a universal comparator that can be used to monitor any analog actual values measured or calculated by the IED, or a net difference of any 2 analog actual values of the same type. The input 1 specifies the first input to the flex element. 0 is the assumed as the input if this setting is set to off. For the proper operation of the element, at least one input must be selected, otherwise the element will not assert its output signal. Input 2 settings specify the second input to the flex element. 0 is assumed as the input if this setting is set to off. For the proper operation of the element, at least one input must be selected, otherwise the element will not assert its output signal. This element can be programmed to respond either to the signal level or to a rate of change over a predefined period of time. This is selected under the input comp, which means comparison mode. Depending on how the flex element is programmed, the effective operating signal could be either assigned or absolute value. The output signal is asserted when the operating signal is higher than a threshold when the setting is set to over, or lower when the setting is set to under. The threshold is the setting of the pickup in the per unit, PU, and for the base unit of each type of the analog input, please refer to the instruction manual. The hysteresis controls the element to drop out. The ROC/OT, rate of change of time unit, dt, this specifies the time base dt when programming the flex element as a rate of change element. The ROC/OT setting specifies the duration of the time interval for the rate of change mode of this operation. So ROC/OT unit and ROC/OT set, these two settings are applicable only when the input comparison mode is set to delta. The pickup and the dropout delays specify the pickup delays and the reset delay of the element. And inhibit is used to block this flex element function, and this element can also activate the output relays from 2 to 12. In the demo session, we're going to demonstrate the 3 demos. The first one is the PSL logic gates. We're going to use the AND gate, OR gate, SR latch gate, and non-volatile latch gate, and program them into the programmable LED 5 to 8. And in the second demo, we're going to demonstrate oscillator by using the inverter of the logic. And the last one, we're going to demonstrate the flex element by using the ground current input and set one overcurrent element of the ground current input. In the logic gate demo, we're going to use two contact inputs up to input 1 and 2 and assign into 4 logic gates: AND gate, OR gate, SR latch gate, and non-volatile latch gate, and with the set dominant. So first we're going to grab two inputs, contact input 1 and 2. So this is the up to input 1 and then up to input 2. Select the family to be contact input 1 on. So we got two inputs, and we're going to get 4 gates. So the second one can be set to the OR gate, and the third one is a latch gate. Okay, so from here we can click the link and to connect them to the inputs. So the first will be the AND gate, second will be the OR gate, third will be the SR latch gate. Then we're going to assign them into the different LED. So the first one, we're going to assign them to the LED 5, to the red color. Just to grab all the LEDs. So the output of the AND gate assigned to the LED 5, red. Okay, for the LED 8, we want to use this to be the non-volatile latch, so we have to assign individual non-volatile latch for this one. So we have to select the family category for the non-volatile latch, and that's the second from the bottom, non-volatile latch. I'm going to select a non-volatile latch 1 on, and this will be configured later in the flex logic. But for here, we just connect this to be the 8 LEDs. So for the AND OR gate, SR latch, and non-volatile latch being assigned to the 4 LEDs. Now we have to click the Save button. Then once we close this PSL Editor, these are compiled, and for now I'm connecting this to the relay, so this CID file is sent into the relay. So once we see this CID loading in progress until the OK button become solid, then we can click OK. Then we can see this reserved virtual output from 121 to 126 are being assigned for the different LEDs, and we can check these settings from the front panel LED, and we can see this LED being assigned, and also we can check the flex logic non-volatile latches. From here we're going to use the virtual use the contact input 1 to set as a set, and reset is up to input 2 on, and this is the set dominant. This is just a comparison with the SR latch, which is a reset dominant. So for now, we are ready to do the test, and we can check the status from both the monitoring and from the relay front panel. Now we're going to check the logic gate by monitoring the status of the opto inputs, virtual outputs, and also the front panel of the relay. So first, we can see from the front panel, LED 5 to 8 are all turned off. And now we're going to turn on the opto input 2, and then we can see the LED 6 turned on, and on the virtual output 126 turned on. So now turn this off. And for now, this test, we just can ignore that the alarm from the breaker status. And second, I'm going to turn on only the opto input 1, and we can see that the LED 6, 7, 8, 3 LEDs turned on, and from the virtual output we see the 122, 126, 124 turned on. And lastly, I'm going to turn on both opto input 1 and 2. We can see that LED 5, 6, and 8 turned on, and on the virtual output is the 122, 126, and 128 turned on. And that's exactly matched to the status, the table. The last test I'm going to do is the latched, non-volatile latch and the volatile latch gate. So from the front panel, we can see that the LED 7 and 8 both turned on, but the inputs are all turned off because they are in the latched mode. Now I'm going to power cycle the relay, and after power cycle the relay, and we're going to check the status. Okay, so now relay finished the rebooting. We can see the LED 7 is off because that's the volatile latch, and LED 8, the lights still turned on because that's the non-volatile latch. Means when you lost the power is back, that's the latch stays on. And that concludes all the demos for the logic gates. In the second demo, we're going to create an oscillator, and the turning on and off at the 2 seconds. Every 2 seconds, turn on and off. So first, we're going to apply one virtual output. And I'm going to select virtual output 1 and assign this through the AND gate. And we put this invert output, so this become a NOT gate. In order to make this NOT gate working, we need to assign one on operand. So that means this will be permanently on and become inverter. Then we're going to apply the timer. This will be a pickup and dropout, and we set to 2 seconds. That's 2000 milliseconds for on and off. And this will be applied to the LED 5. We should not set latch because we want to keep this turn on and off. And this one will be assigned into a virtual output first. Virtual output 1, then assign into the LED 5 red input. So now we click link and connect all these connections. this will be assigned with a virtual output 1. To the input 1 of the LED 5 of the red input 1. Okay, so once all finished the logic and we click save, then we can exit and this will be uploaded to the device. Then we can do the test. Okay, so the setting is now uploaded to the relay. We can see that the front panel LED 5 is turning on and off. This is the timer delay of 2 seconds. Every 2 seconds, turn on for 2 seconds, then turn off 2 seconds. So that's the oscillator by using this inverter of the AND gate. In the last flex element demo, we're going to program an overcurrent for the ground current input. So we'll first need to enable the flex element 1 and select the input to be the CTIN1, that's the ground current input. And then input 2 will be off, comparison mode will be level and absolute for the operating, and signal direction will be over. And the pickup level is set to 1.1 pu, and the per unit is based on the Earth fault CT primary and secondary. For the demo, we set this to 1:1. That means the Earth current need be higher than 10% of the nominal current, so that will be 1.1. This element will operate. And in order to monitor the operate, we set the LED 8 to be the flex element 1 pickup for the red color and green for the operate. So let's see the time delay between the pickup and the operate. So the pickup delay is 3 seconds. That means after 3 seconds, the green input will turn on. That means the LED 8 will be first turned on by red when the current is higher than 1.1. Then after 3 seconds, we'll change into the yellow color because the red input is turned on. And the hysteresis is the dropout, and rate of change is not applicable for this demo. So we're going to save this setting and start the current injection from the front panel of the relay. So first we select the metering to the IN, so we can monitor the status of the IN current, and we see the LED 8 is still not turned on yet. We're going to increase the current slowly to 1.1. Now let's recap what we learned in these training modules. First, we introduced the PSL Editor. So there's different options. You can use the minimum editors, or you can enable some different functions on the toolbars. And then in the input-output signals, we introduced the different categories. By using one P40AE relay, we showed that there are 39 categories, and what is the different operands under each category. And we use the UK English as a demo, but that category is the same in the US English, just the operand will be slightly changed, especially on the protection elements. Then in the LED contact conditioner, and we introduced the different modes, especially the pickup mode, dropout mode, dwell mode and pulse mode, and there's a straight through and latching. The main difference between the dwell mode and the pulse mode is that the dwell mode have a output is corresponding to the input. If that's longer than the minimum delay time, that output will be the same as input. But for the pulse mode, the output is always a definite pulse time. And in the timer, we have this similar kind of the different modes, pick up and drop out, similar like the contact conditioner. And in the logic gate part, we introduce the AND gate, OR gate, and both of them can be configured into other gate, and there's also a inverter as an output. And the SR latch gate in the PSL is reset dominant, and it's volatile. That means once you lose the power, that latch status will be lost. Then in a separate setting of the non-volatile latch gate under the flex logic, which you can choose set dominant, reset dominant, and that latch will not lose when you're losing the power. And finally, we introduced the flex element, and we introduced the different settings. And lastly, we did a demo with the logic gates and the oscillator and the flex element of ground current inputs of the overcurrent. So that concludes this training modules of the 106 PSL Editor. Thanks for watching.